this is Stephen DeMarney, and today we're going to start lesson 8A, and our goal is to make a tethered robot that is controlled by two double throw switches. But first I'm going to show you the parts we're going to use. We're going to be using a double pull double throw switch, and I'm going to show you how to use that to make an electric DC motor go forward and reverse. And we're going to use our 6-volt battery pack with 4 AA cells, and we're going to use the Dagu robot chassis, and I'm going to show you its DC motors underneath. So there you can see this is actually the gearbox, and it says Dagu robot, and it's a 48:1 ratio gearbox. And here's the DC motor, and you can see there's a red conductor and a black conductor for each motor, and there's 2 motors, and then at the back is this little roller so that the robot can move. So I'll just flip this back. And we're also going to use a second switch, but I'm going to show that later. First I'm going to show how to make one motor go forward and reverse, and later we'll use both for both motors. And then we'll make a robot with a conductor tether so that we can follow the robot around the house and control his forward, reverse, and steering. Now I'm going to show you how to wire the battery and the switch and the motor. And we're going to start with the battery first, and I'm going to connect the battery up to this terminal here, one of the throws of the switch, but at the same time I have to connect a jumper to the same terminal as the battery. And this is not so easy to put 2 jumpers under this single screw terminal, but we're going to try very carefully. Sometimes it might help get somebody to help you to hold the conductors under the screw. So I'm just going to pause now and get it done. Okay, now I've got the positive lead of my battery hooked up to this throw terminal as well as a jumper wire. And now next we're going to hook the negative lead of my battery terminal. We're going to hook it up to this throw, but at the same time I have to hook up another jumper wire to this same terminal. And I'm going to do that and show you the result in a second. Okay, now I have the negative terminal hooked up to this throw terminal, and a jumper also attached to the same terminal. And now our next step is hooking up the jumpers to the opposite set of the throws. And the most important thing for reversing a motor is you notice the wires are crossing over. So the negative terminal is crossing over with this wire to this corner, and the positive is crossing over to go to this throw terminal on the opposite corner. So now I've finished wiring my crossover wires to the opposite throw terminals. And our next step is we're going to hook up the tether conductors which go between the throw terminals and the left motor terminals on our robot. And for that I've made up along what I call a tether conductors, and I've just coiled it up. It's about 2 meters, and we're going to connect the one end to the robot, which is quite easy. So I just put one wire to the positive terminal of the motor, and polarity doesn't matter at this moment, and the other conductor connected to the negative of the motor. And now I'm going to connect the screws at the throw terminals here to these two screws, and then I'll just take a short pause and hook these wires up and come back. So now I have my tether conductors hooked up to the poles of my switch, and next we're ready to put in the batteries, and I need to bring my switch into the middle position so that the motor is off, and I'll install my batteries. And again, for batteries you have to be careful to put them in the correct position as the battery holder shows, so you get your 6 volts. You don't want to put a battery in backwards, you have to make sure they're put in according to the correct polarity. Okay, so now our circuit is ready to go, and I'm going to flip this up so you can see the left motor, and then we're going to demonstrate the motor going forward and reverse. Okay, so now the forward direction I want for when I put the switch forward. Okay, so that's actually going backwards. So what I have to do is I just need to reverse polarity of my 2 tether leads, and then the motor should be going forward. So I just reverse these 2 if the motor's going in reverse, and now we'll just test this. I'll just leave it down and see if it goes forward with that. Yep. So that's forward. And then if we go, I'll just put it on the side again, and if I go back, now it's going backwards, forwards. So this is how you can make a DC motor go forward and reverse, by using a double pull, double throw switch. But the most important thing is we're using this crossover to change the polarity. So when I go this way, I'm going positive and minus, and this way it's going minus and plus, which changes the direction of the DC motor. So next we're going to hook up, I'm just going to hook up the other switch with another tether of wire, and I'll show you that when that's ready, and then we're going to try out our tethered robot on the floor and see how it goes. Okay, now I've wired up the right switch exactly the same as the left switch, and I'm just going to put these switches in the middle and reinsert my battery, and we're just going to test this wheel now, the right wheel, to see if it's going forward when I go forward. Yes, it's going forward, so we don't need to reverse the wires, and then reverse. Okay, so now our robot is ready to try with the tether control. So I'm going to set up in the hallway and we'll show you the robot working by tether. Okay, now I'm going to demonstrate how to use the tethered robot, and here's my 4-conductor tether, and I've got it secured to the robot so that it won't try to pull the wires out of the solderless socket. And I've got my 2 double pull, double throw knife switches, and you can notice right now they're in the middle position where there's no connection to either of the throws. My pulls are centered, so there's no electrical connection, and because there's no electrical connection, the robot is stopped. None of the motors operate. Now I'll demonstrate by moving the left double pull, double throw switch forward, and that will make the left motor go forward, and so our robot will turn to the right with the left motor going forward. And then if I reverse it, the motor is going to go backwards and turn to the left. And I'll just straighten it out a little here if I can. It's not easy to control. The motor and the gearbox is very fast with 6 volts. Oh well, not perfect. There we go. And now if I put the right switch forward, the right motor is going to go forward and it's going to turn to the left, as you see there. And then if I go with the right switch in reverse, the right motor goes in reverse and it's going to go backwards and turn towards the right. And now I'll try to go forward with both switches, and it should go approximately straight forward, but it won't be perfect because it's hard to control both switches. There we go, going forward. And now I'm going to try to go both backwards and see if I can control it. Yeah, somewhat. Okay, now I'm going to lift the tether up and we'll see how well I can steer it around in the field of view of the camera. See how well I can steer. It's kind of tricky with these knife switches because one knife switch is stiffer than the other. I'm going to try reverse, probably outside of the view there. Try to go back forward. So it takes a lot of practice. Yeah, I'm probably outside of the view again. You have to keep your tether clear. And it's easy to spin in circles. Yep, there I go outside again. Oh, now I'm stuck on the carpet. I'll just bring it back in. We'll try again. So yeah, with lots of practice you can get quite good at using the and then in our next lesson we are going to use some double pull, double throw relays and push buttons, and it'll be a little easier to control the robot instead of using these switches. But I wanted you to see what the switches first so you could understand the theory of how the double pull, double throw relays work, because you can't see the contacts in them. So we'll see you for the next lesson of making your own robot.